All right, welcome back to our series in AP Computer Science Programming in Java. This is a part of our Classes and Objects unit. We are talking about inheritance. And hopefully you've watched the previous videos that introduced inheritance, how it works, what are the benefits. But as a quick preview, I'm just going to say that inheritance is the act of creating a subclass of another class. And the example we've been using is we have a class dog that extends animal, and dog, by doing this, receives just about everything from the animal class. This means that dogs have a public field that's of type string that's called name. They have a private field called int age. Animals can eat, and dog would have been able to eat on its own, but we chose to override eat, meaning that dog defined its own way. Just because we're going to be adding more code to these examples, I've used the minimize feature that Eclipse has. You can do this to make your code expand or contract. And just to help get it out of the way, I've shrunk most of the code. Let's tackle a difficult notion, which is how does inheritance and constructors work? Because I've tiptoed around this so far saying that subclasses inherit everything, and the real answer is that they inherit almost everything. So let's see what it is about constructors that are not inherited, but even more confusingly, why it would appear that sometimes they are. So what I'm going to do for right now is I'm going to go ahead and define a constructor for my superclass, which is animal. We recall that constructors are a method-like definition of how to create a new object. And one of the reasons that we often define a constructor is because we want to initialize the state of our object, right? Without a constructor, if I want to make an animal, I can say animal al equals new animal. Okay, fine and dandy, except if I want to populate, Al's name and Al's age, I got to say al.name equals, we'll go with Monty is my cat's name, or was, and then let's go with al. Now remember, I can't just say age right here because I've encapsulated age. I can't just say that Monty is 9. Because as we observed in a previous video, with this being encapsulated, we no longer have dot access to this field. So if I want to change the age, I need to do it in a way that's approved. So we say dot set age. I'll set Monty's age to 9. Okay, I can do this, but gosh, wouldn't it be easier if when I create the object, I can just go ahead and set the fields at the same time? And that's what our constructor is going to do for us. So constructors, we recall, have no return type. And it's not that, whoa, what happened to my code? Oh, it just got eaten there a little bit. That's okay. Constructors have no return type, and which isn't to say that they have void. They have nothing. You just say public animal. There's no void. There's no int. There's no type right here. This is how we signal to Java that what it is we'd like to define is not a method called animal. We want the constructor animal. The requirements are nothing between the public and the name of the constructor, and that the name must exactly match the name of the class. That's how we make a constructor. All right, well, to make this a shortcut, let's go ahead and require, well, I'm actually going to pause here for a second. Rather than make a good functional constructor, I'm going to go ahead and say animal constructed. So all this constructor is going to do is it's actually not going to shortcut anything. I'm not going to use parameters to initialize some of my fields. I'm just going to go ahead and announce that whenever I construct a new animal object in the console, it should say animal constructed, because I'm going to try and prove a point. We'll get to the better constructor in a moment. So when I go ahead and run my code, boom, it says animal constructed. The reason it does that is because when it executed this particular line of code here, it went and found my constructor, bam, made me an animal, and we're good to go. All right, well, let's make a dog. Dog D equals new dog. And you've heard me say State is inherited, behaviors are inherited, constructors are not inherited. Except watch what happens right here. I'm going to go ahead and clear the console. I'm going to go ahead and run it, and whoop, it says animal constructed. That can't possibly be correct. But when I look at the code, what I need to understand is that there are a few things that Java is doing to help me. So I'd like to introduce the rules of constructors and inheritance. I'm going to call it the rules of subclass constructors. That's actually a much better way to describe it. Constructors. Okay. Rule number 1, if I do not provide a constructor, Java will. That's rule number 1. And we've talked about this in previous tutorials, but the idea is if we don't define a constructor, Java makes us a constructor that has no parameters, has no body. It's called the default constructor, which is why we're allowed to, before I ever defined this animal constructor, I could make animal objects no problem. So if I do not provide a constructor, Java will. That's rule number 1. Here's the next rule. It's not going to make sense till we talk about this new particular keyword, but just hear me out for a second. Rule number 2 is subclass constructors must begin with super and must refer to a matching parent constructor. Whew, that's a mouthful. Let's break down what's going on here. Well, in a moment, you're going to see that I'm going to use the keyword super in our subclass constructors to call the parent constructor. And there are reasons for this. They're a little hard to understand. Be patient with yourself when you're tackling this. But the idea is this. Before I can make a dog, I must address whatever needs there are for building an animal. So maybe what that means is, animal has the field name and age. Well, I would like to go ahead and assign the fields for name and age. I would finish the construction of the animal part of my object in some sense. And then I'm allowed to take care of whatever it is that dog needs to do. So you're going to see some code that elaborates this in a second. But rule number 2 is subclass constructors must begin with super and must refer to a matching parent constructor. And then the last thing I would say, rule number 3, which is how we just got the confusing code that just spat out, is if I don't call super, Java will. Or Java, which is a new programming language coming out this fall. Just kidding. Okay, so what's going on here? Let's show what super looks like. I'm going to go ahead and say the best way to describe how super works is I'm going to complicate my animal constructor a little bit. I'm going to go ahead and add some parameters. Let's go ahead and get a string name, and int age. These are what I'd like to assign to my various fields. Name is public. It's not encapsulated. It's exposed. So I'm just going to go ahead and say this.name equals name. And remember, we use the this keyword because I'm expressing that this name should refer to the object's field, while name should refer to the parameter. That way I actually get done what I need to get done. And in observance of appropriate encapsulation, I wouldn't just want to say this.age equals age, because I run the risk of having that invalid state, right? What if I accidentally set the age to negative 300? So to make sure that I'm behaving myself, I'm going to say set age to age. Let me make sure that works. Okay, good. All right, so now I have this constructor, and I'll clear it, and I'm getting ready to run. I save constructor, I get all my classes saved. I go to run, but then I say, oh, wait a minute, look, there's an error in my dog class. And let's see what it says. It says the implicit super constructor animal is undefined for default constructor, must define an explicit constructor. All right, so here's what happened. We've said, look, when you build an animal, the only way to build an animal is to provide two parameters, a string and an int, because we've got work to do. We've got responsibilities to make sure those fields are fine. When this was not true, if I take this out, which I think will break the code in a number of different ways, but with that gone, what we're saying is, you know what, when you build an animal, you don't need any parameters, don't worry about it. So that sneaky, helpful stuff that Java does for us behind the scenes in dog, we didn't define an explicit constructor, so it made us an implicit default constructor. Then we didn't call super, so it just assumed that it would call super for us. And it was able to do that because animal has no requirements, not a big deal. But as soon as animal has requirements, then we're in a little bit of trouble. Okay, so this brings us to, let's not rely on the in the background stuff that Java's doing to help us out. Let's go ahead and define an explicit constructor here because then we can know what we're doing. Okay. So I'm going to go ahead and make a constructor here. And we know it's a constructor because of how I write it. Public, nothing for return value, dog, oh, thank you Eclipse, dog. Okay, now I might think to myself, whenever I make a new dog object, I'm going to have to get some information to the animal constructor because a dog is an animal. When I build a dog, I have to provide the information needed to build an animal. So what I might say is, all right, string name, int age. When you build a dog, you must also build those things. And then here I go, super name age. All right, what in the world is going on here? What I'm saying is, when I build a dog, I will take in these two parameters, and then I will go past them using the super keyword up to the constructor for animal so that it can be passed to this correct code that does this work for me. And now Java feels satisfied that we are meeting our responsibilities. All right, if you want to have a subclass and you want to construct that subclass, and your parent has any complications, any wrinkles whatsoever, you have to address those. The way that I call super in the constructor right here has got to match whatever kind of constructor was defined up here. For example, a good way to think about this is I might make another constructor. Remember, you can overload constructors just as you can. Methods. And let's say I want to build an animal and I don't provide any information for that animal. We're just going to make some assumptions. We're just going to say, look, if I am too busy to assign something, then I will call my no-name animal, we'll just have the name no name, that's really depressing, and I will go ahead and set age to 1, okay? What this means now is there are two different ways that I can construct an animal, okay? And if I want to, I could say, you know what, dogs, dogs will take no parameters, and I'm just going to refer to the no parameter constructor up here so that all dogs start with the name no name and an age of 1. Or if I wanted to, I could say, I could put back those requirements, and now I'm referring to the other constructor. So why did I do all this? Let's refer to the rules. Rule number 1, if I do not provide a constructor, Java will. At this point in the video, I hope it's pretty clear, we generally don't want to rely on Java making our constructors for us. If they are very small, very simple classes, if there's not any inheritance hierarchy, they're just a standalone class, maybe you can get away with it. But in general, if you're defining a class, it's going to have fields. You're going to want to put values in those fields. You might as well make a constructor so that you can assign the values to those fields more quickly, number 1. Number 2, subclass constructor must begin with super and must refer to a matching parent constructor. So before I do anything else, I can put other code here That's totally fine. But if I have a subclass, dog is a subclass of animal, and I want to define how to build a dog, the parameters I use here may or may not necessarily be important. We can talk about that later. But I got to start by calling super, and whatever parameters I pass right here must match parameters given up here. If the only way to build an animal was with no parameters, so let's say I take out the constructor with parameters, and now I try to refer to the constructor with parameters here, Java will rightfully balk. Whoops, well, don't do that. Java will say, what are you doing? I don't have a constructor that takes a string and an int. I don't know why you're trying to pass this. So rule number 2, make sure you start with super and that it matches a constructor in your parent. Rule number 3, if you don't call super, Java will. And what that means is if I don't put any code here, if I just try to make this blank, then Java will sneakily put this code in for me. And the only way that sneaky code works is if you have a parent that is comfortable being constructed with no parameters. So when we get back to our original scenario earlier, I'm going to go ahead and rewind the code a bunch of things are going to get deleted. So if you need to rewind to this point in the video, that's totally fine. But I'm going to get rid of this parameterless constructor. And actually, I'm going to turn our parameter constructor into a parameterless constructor. Let's revisit this initial scenario that had gotten us into such a mess. And I'm going to put no constructor in the dog class. Okay, and I go and I say, so what I've got here is there is a single constructor in the animal class, and it says, look, when you build an animal, provide no parameters and just print to the console animal constructed. And dog has nothing. And so, okay, fine, dog has nothing. When we went and ran this, it still said animal constructed. And the reason is sneaky Java added this code in while we weren't watching. They said, all right, public dog, no parameters, that's the default constructor, and then a default super call. And what this does, this sneaky code that Java added, it's not inherited. This is just Java assumes if we don't define a constructor that it has to, that if it's providing a constructor for a subclass, that it'll call super for us. In fact, I think, let me see if I get this right. I think I can say dog constructed, because while Java's trying to be sneaky, let's see if this compiles. Do it. Yes. If we don't provide a constructor, Java does. If we don't call super, then sneaky Java will put a parameterless super call in for us. So here we are at the end of this video. I know that this has been confusing. Here's your summary. When you define multiple classes that are in an inheritance hierarchy, you're going to have superclasses and subclasses. Because your classes are likely to have fields, meaning that they're going to have their own variables like name and age, you're probably going to want to have constructors to make building those objects easier. It can be done in one line instead of many lines. As long as you're defining constructors for some of the classes in your inheritance hierarchy, you must remember that your subclasses must have a constructor who calls super in a way that matches. And if you don't define a constructor, Java will. If you don't call super, Java will. And that is that video. You hung in there to the end. Gold star. Nice job. I'm impressed. Thanks for watching.